a general idea and flavour. And so specific co-Is may have slightly altered talk titles from what's in the timetable. Obviously, none of the co-Is wrote their talks last night, and they've all been very well prepared beforehand. But so some of them may be slightly different. So Mike, I'm not entirely sure what your talk title is, but Mike is going to be talking to you about the education work. So Mike has been leading on modelling work both within schools and within the university campuses. So I think he's going to speak to you about university, and then is Louise speaking about the schools later, Mike?
Yeah, I believe that's true. Yeah.
Right, great. Well, with that, Mike, I will pass over to you. Thank you very much.
Yeah, thanks very much, Kira. Yeah, I definitely didn't write my talk last night, honest. But no, I'm going to, Louise and I were going to do a bit of a tag team, but we've had to rearrange things a little bit. So generally this comes under the blanket of education, but we're splitting these two. So I'm now going to focus on higher education, and then Louise later on in the day will talk about the work that we've done within schools. Now, what I'm going to present in this sort of next 15 minutes is really work that not only has been done by members of the JUNIPER consortium, but really primarily has actually been done by a group at the Isaac Newton Institute Higher Education Modelling Group, of which all the authors are below. So I'm really presenting a lot of work that is not mine. So I will do my best to try to give a representative summary of the work that we've been doing earlier on this year on this question. Just before I start, though, I just wanted to give a little bit of a history of the work that we've done on higher education. And really, this goes all the way back to summer last year, where there was an awful lot of uncertainty around what students would face coming back to campuses, whether they'd be able to get back to face-to-face teaching, and whether we'd need mitigations in place to manage risk. So back in June last year, there was a meeting, a virtual study group meeting on unlocking higher education spaces, which was hosted by the Virtual Forum for Knowledge Exchange in the Mathematical Sciences, which has the acronym of VCHEMS, and there was a working paper that was published on that. But this then followed with a couple of virtual events run through the Isaac Newton Institute, and you know, there were various different kind of papers that were published, review papers as a result of this, and a couple of modelling papers as well. And then beyond the summer last year, the Isaac Newton Institute Higher Education Group formed, and we started to meet virtually on a weekly basis to really look at risks associated with university campuses. And the group was comprised of, well, 9 different universities were represented on this group, with various different sort of academics and early career researchers who were forming this group. So our main aims really at the time were to go back and really try to understand what we could learn from the first term. We really were sort of monitoring the data over September and December, from September through to December, and then looked at exploratory modelling of the return of higher education students in the new year. And by the new year, I mean the new year in 2021 here, not 2022. Now, of course, there were some caveats that I should issue at the start of this, that a lot of the analyses that I'm going to talk about were based upon insights that we gained from very particular institutes. And so we very much, when we were presenting this work, said very much focus on the high level qualitative insights rather than the quantitative specific findings from any individual model. And of course, and this is something obviously that's very close to my heart, we very much focused upon transmission dynamics. We didn't explicitly consider all the negative impacts such as education, long COVID, and mental health and well-being, of course, and we know that those are extremely important. So to start with, say we really were looking at getting some, learning some observations from the first term. And so what we did, there were a number of different analyses that we looked at, and I'm going to go through these sort of a slide at a time. But initially we looked at what might we be expecting to come into university campuses at the start of term in terms of incoming infections. We looked at risk in university halls of residence, and then we're thinking about the transmission to and from the community and the risks associated with that. So I'm going to go through each of these in turn. So to start with, I mean, this is a relatively sort of simple model that we developed to look at incoming risk to university campuses. So what we did is we used the home lower tier local authority of the incoming student and used that to estimate the likely number of incoming cases onto university campuses at the start of the academic year 2020 to 21. And then based upon what we were observing on campuses in terms of outbreaks, what we did is we estimated what the outbreak probability would be based upon the expected number of incoming cases. And you can see the stars here on my graph are the observed fractional institutes with an outbreak, given the expected number of incoming cases. And then effectively what we did is we fitted a curve to that to estimate what we thought the outbreak probability would be dependent upon the expected number of incoming cases. And essentially the key message here is that really the observed patterns of what we were seeing at universities in terms of outbreaks were very consistent with what we might expect in terms of the number of incoming cases onto campuses. We also looked at risk in halls of residence and how that risk may vary based upon hall size and based upon the proportion of individuals that shared facilities. And in particular here, we were looking at shared bathrooms. So we did a very simple sort of multivariate regression analysis. Then this was data that was collected on one particular university from an individual within our consortium. Very simple take-home message here that students living in larger halls were, and you can see this is based upon secondary attack rate that we're giving in this table, were at higher risk of contracting infection in the autumn term. We did not find evidence of a dependence of household secondary attack rate on household size, but as in household being students that shared facilities within a hall of residence, suggesting that actually it was the overall hall capacity rather than structure within the hall of residence that was really actually influencing the likelihood of large outbreaks occurring. And finally, in this kind of retrospective analysis, we were really interested in looking at interaction between the universities and the community. So if we look here at daily incidence and growth rate through time from September through to November, you can see kind of our student age groups, the 18 to 24s here, given by the black lines, and other age groups given by the red lines. And you can see here there's a big spike at the start of university term in the university age individuals, but we did not find a statistically significant increase in the growth rate within the community across the board following this spike in cases. So what we then did from this is we kind of delved down a little bit further into this and said, well, actually, how does this vary on a really local scale? So what we did was we looked at middle super output areas, which is kind of a level below lower tier local authorities, and characterized those based upon MSOAs with a high concentration of students, given by my black lines, and near high concentration, i.e. 2 kilometers or less from a high concentration area of students, low concentration of students given by the blue, and then the green one, which is MSOAs far from a high concentration student areas. Now, the key thing to take here, I'm giving you examples here from Manchester, Birmingham and Hull. You can see there is no consistent pattern. If we look at Manchester, we can see that we're getting a spike again at the start of term in high concentration student areas, which is then followed by a lesser spike on the red curve in those areas near to high concentration student areas, indicating that there's some kind of spillover effect going on into the community. But the same is not observed in other areas. In fact, if you look at Hull all the way to the right, we are finding a consistent pattern across MSOAs in terms of the growth rate of the infection. So no consistent pattern between different areas with student populations. So this was kind of our historical work that we did. So just to conclude this part, we did conclude that the distribution of outbreaks in universities was pretty consistent with importations. Larger halls of residence appeared to pose a higher risk, and, well, really transmission from universities to communities is complex. Clearly, we believe that spillover can inevitably occur, but there was no consistent pattern between student communities and other regions, and that should say MSOAs, not LTLAs there. So having done this work, we then were looking at prospectively, what might we expect to see in January 2021? Of course, most students were doing a lot of their work remotely and many were working at home for the first term, but there was a real focus on how can we get students back to university campuses safely. And the question of staggering student return came up. So we were looking at this. We were also looking at the effectiveness of testing students on return and the potential effectiveness of mass testing of students throughout the term. So I'm going to start off with the first part of this, and this is just a very, very simple kind of toy model just to characterize this. So what we're going to do, just to kind of get an idea of the impact of staggering, is let's assume that N students are returning to campus in 3 equal stages in the first 3 weeks of term. So populations come back over those periods of time. And then once at university, students interact without any restraint. And then upon return, we assume that a particular fraction, P, of those individuals coming back are infected. And then we can run a model to look at the impact of staggering compared with all students returning together. And I hasten to add, this is a very simple SIR toy model, just to give an idea as to what we might expect to see. So we have a population of students given by N, we have a transmission rate, we have a recovery rate, and we have a fraction of individuals coming back infected. And you can see here that the staggering result is on the left, and then the no staggering is on the right. And you get an influx of incoming susceptible students given by the blue lines here coming in. And of course, that delays the infection peak, the red line coming in here. But actually, over a longer term, the number of recovered individuals is pretty much saturating at the same point, indicating that the long-term impact is relatively small. So this is really the starting point to think about this. But then we looked at it with some more sophisticated models and thought about different strategies for students to return to campus. So again, we have kind of a no staggering given by my blue line here, where all students basically return over the first weekend of term. And then students return sort of uniformly over the first 14 days or uniformly over the first 28 days. And then a pulse sort of method where students return over 3 different weekends over the course of term, just to get a sense of the different impact of these types of strategies. So we developed a couple of models to look at the impact of these. The first one of these was a network model where we had a student cohort of 25,000 individuals, some on and some off campus. And we considered that these students could mix either within their own household, within their field of study, within organized societies, or in other social settings. And we assume that if an individual was not isolating, then those contacts, of course, do not occur, but the corresponding individuals yet for the corresponding individuals not having returned to university, there are no other contacts that are made, of course. And then we consider different testing strategies where 2 lateral flow tests spaced 3 days apart were administered, and then there was isolation in between those tests. And of course, the test sensitivity was dependent upon the time since infection. Okay, so this just summarizes what we see. So the relative attack rate is given on the y-axis here, and the likelihood of students adhering to test, trace, and isolate is given on the x-axis here. Now, this is a very complicated graph with all the different staggering strategies here, but the key take-home message, the one thing I want you to take here is adherence to NPIs, to non-pharmaceutical interventions, is really key. That has much more of an impact than any marginal benefits generated from any kind of staggering strategy, which was really interesting and actually very much supports what we saw with the really simple model. So just to kind of show this, if we look at sort of a 0% adherence and no return testing, then you can see the different kind of staggering strategies here in terms of infection, the proportion the proportion of initial susceptibles infected, and the sort of the R number through time. And you can see there is some variability in the different strategies in terms of when when sort of the peak of infection takes place. Obviously, if you're staggering more, you're pushing the can down the road, as it were, in terms of when the infection peaks. But you're getting very similar sort of numbers of cases over the entirety of term. If you do have 100% of students adhering and all engaging with return testing, then the risk of any kind of large-scale outbreak on campus is significantly reduced. And obviously, this is really important, which again indicates that adherence is really key across all of this. But what about the impact on students themselves? And this is obviously very important. What we looked at was, well, what would be the impact on the amount of time that students would stay in isolation dependent upon the likelihood that those students would adhere to the rules. So there's two different graphs here. If you look at the one on the left, this is for all the students, the proportion of time spent in isolation averaged over all students. And what you can see, of course, is that as more students adhere to test, trace and isolate, then of course, more students are spending time in isolation. But this saturates when you get to a sort of a critical threshold of adherence, because of course, that's then having a positive impact on the epidemic within the campuses. And on the right, this shows you the proportion of time in isolation per adhering student. And this kind of highlights that actually, if you have very, very low adherence, if you end up, as in sort of 10, 20% adherence, if you end up getting more students to adhere, then actually for the short term, this actually makes it worse for students that are adhering, as in they have to spend more time in isolation. But if you can get beyond that critical threshold of numbers of students isolating, then in the longer term, this is beneficial in terms of reducing the proportion of time in isolation per adhering student. Okay, so that was a network model. There was some comparative analysis done by a group looking at a kind of a stochastic compartmental model, looking at very, very similar questions here, and similar sort of staggering strategies, none, the 14-day, the 28-day, and this 3-week pulse. And we did find very similar results, that actually you get slight variability in terms of when your peak occurs, but actually the overall case burden is very similar across all considered staggering strategies. What you do find is that you get lower prevalence for 14 and 28-day staggering in the early phase of the infections given by the graph on the right, but higher prevalence in a later phase than you would if all students return at the same time. Okay, so that's the work that we did on staggering. The last thing I want to talk about is thinking about the impact of testing on university campuses through term. So what we looked at was, could regular mass testing play a role in reducing the risk associated with campus-based outbreaks? So again, we developed a SEAR network model to look at this, where we included pre-symptomatic and asymptomatic individuals. And again, relatively simple assumptions in this model. We assumed a 50% probability of each non-household contact of a test positive being traced and isolated, and assumed that the household immediately isolates upon a positive test or symptoms. And we considered 2 variants here. So again, this is probably quite relevant to the situation we're facing at the moment with the emergence of a new variant. Back when we were doing this, we were thinking about the emergence of alpha, which seems like a very, very long time ago now. But we were thinking about, let's consider 2 variants with differing transmissibility. And very simple assumption here, we just assume that the higher transmissibility variant has transmission increased by a factor of 1.5. And then we considered the impact of no asymptomatic testing through term, and then testing every 3, 7, 10, and 14 days. And then we looked at the impact upon the total number of cumulative cases that you would observe through term with these different testing strategies. Now, the key take-home message here is, if you have the lower transmissibility variant that we were looking at here, then any form of testing, even testing every 7 or 14 days, is relatively effective at reducing the overall number of cases that you would observe through term. But of course, unsurprisingly, if you have a higher transmissibility variant, then you can see that the impact of no testing at all is really quite dramatic, and you do need to be doing regular testing to really reduce the impact of spread on university campuses. Okay, so that's really all I wanted to talk about today. So just to kind of conclude this section, staggered student return does appear to be of somewhat mixed and limited value. It could potentially reduce the need for self-isolation on return, but there are other impacts of that. If you're in a high prevalence situation, you may end up with lots more individuals in isolation. A staggered return could delay and reduce the size of any outbreak, but staggering on its own will not substantially reduce the total attack rate over the whole term. And clearly this is very important, but level of student adherence is key. You know, we did find throughout, and again, I'm sure no one will be surprised about this, that it had a far larger effect on any sort of idiosyncrasies between different staggered return regimes. And of course, the big one, again, very relevant for what we're dealing with right now, in the presence of a more transmissible variant, regular mass testing clearly has a decreased ability to control case numbers. So that's all I wanted to talk about. All of this work is now in a paper that's been published by Royal Society Open Science. And I hasten to add again, everything that I've talked about today has been done by this fantastic network of authors who have led various different aspects of this study. Okay, so I will leave it there, but happy to take any questions if there's time.
Right, thank you, Mike. So there's time for a quick question if anyone has any questions. If not, I might abuse my post as chair and just ask a question in regards to adherence. So adherence obviously is very important for any of these measures to work, and you sort of mentioned that in your conclusion slide. Do you know if any people have been, so have you been talking to any of the behavioural scientists about whether they've been looking at sort of trying to measure adherence, how it might have changed over the pandemic? Like, is adherence in the latest term less good than previously?
Yeah, and I think this is a really good point. And I mean, I've had some early discussions about this. I mean, I remember very naively at the start of the pandemic, very much expecting that actually adherence would wane relatively rapidly through the first lockdown. I mean, you talk to the behavioural scientists and that very much was not the case. It does seem that perhaps that is less true now. And I think it will be something that will be very important for us to explore, particularly if, you know, heaven forbid we end up in a situation where we're having to have more restrictions brought in on university campuses next term, with students having had a couple of years now of disrupted education. I think it's really important to explore, actually, do we believe that these interventions that were put in place on university campuses would be as effective next time around? And I think that is very uncertain.
Great, thank you very much, Mike. So we do have to move on to our next speaker, but I should say if anyone does think of any questions that they would like to ask Mike, we do have a panel discussion later. So if you put any questions that you have in the chat, then we will Mike can try and answer them in the chat, or we can try and come back to them later. So thank you very much, Mike. I'll give you a virtual round of applause. I'm sure if we were in the institute, everyone would be, there'd be a great round of applause right